The new asphalt is deceptive. It starts out smooth, dark, almost perfect, but the road doesn't stay frozen on that first day. Over time, cracks, bumps, patches, and potholes appear. Trucks drive by every day, the heat expands it, and rainwater seeps in. The load keeps coming, and that smooth surface slowly turns into a mosaic of wear. The highway is repaired, reopened, and the cycle starts again. But there's still one question left. If concrete can last longer, better withstand heavy loads, and require fewer major interventions, why did asphalt become the dominant material on Brazil's paved highways? The answer definitely doesn't lie in just one cause. Stay with us for the next few minutes and find out why Brazil builds more highways with asphalt than with concrete. A highway isn't chosen just because of engineering. It's also chosen based on the budget, the deadline, the available machinery, and the culture of those who hire for the project. And in this game, asphalt usually takes the lead. The short answer is Brazil uses more asphalt because it's usually cheaper at first, faster to apply, easier to maintain, and supported by an established supply chain. Technically, asphalt usually forms flexible pavement. In this type of structure, the layers undergo deformations and distribute the loads between the surface, base, and subbase. On the other hand, concrete pavement is rigid. The concrete slab has high rigidity and absorbs most of the stresses generated by traffic. In practice, asphalt is simpler for the manager who needs to pave quickly, open the road, and solve the immediate problem. However, the equation changes when we stop focusing only on project completion and start calculating decades of use. If your concrete can last longer, why did Brazil establish asphalt as the standard? To understand this choice, we need to look at the history of Brazilian highways. Paving in the country gained momentum starting in the 1950s, during a period of road expansion, growth of the automobile industry, and the need to connect regions through road transportation. In that context, asphalt was a better fit for the country's urgent needs. It was a faster, more adaptable solution with lower initial costs. In a continental country with many roads to build and limited resources, that weighed heavily. Over time, the choice became part of the technical culture. Public agencies, contractors, designers, suppliers, laboratories, equipment, and contracts came to revolve around flexible pavement. The very development of Brazilian road engineering was largely based on this logic, designing, building, and maintaining asphalt pavements, as well as resurfacing and restoring these structures over time. This does not mean that concrete was unknown or technically inferior. It has always had important applications in industrial yards, airports, port areas, heavy traffic corridors, and sections where asphalt deformation is more critical. But on highways, asphalt became the most common choice. There is also a political and budgetary factor. Public officials usually measure themselves by the visible delivery of a project, not by the accumulated cost over 4 decades. And asphalt, in this sense, helps build more kilometers for less upfront spending. So, what seemed like just a choice of material actually became a national approach to construction, maintenance, and budgeting. The comparison between asphalt and concrete shouldn't be treated as a simple dispute between good and bad. Both materials have real advantages, important limitations, and more suitable applications. The mistake is in automatically choosing one of them without considering traffic, soil, climate, budget, maintenance, and life cycle. Asphalt has a clear advantage. The initial cost is usually lower. It is also quicker to build, easier to open to traffic, and simpler to repair. This scenario explains why it is so widely used on urban and highway roads, where quick construction is needed. Another strong point is the established supply chain. Brazil has a long-established network of asphalt plants, teams used to the work, available equipment, and maintenance contracts focused on this type of pavement. However, asphalt also has its weaknesses, It suffers from excessive loads, poor drainage, water infiltration, intense heat, and delayed maintenance. On corridors with many trucks, wheel ruts, deformations, cracks, and loss of comfort can appear. When defects accumulate, the solution is no longer just superficial and starts to require structural reinforcement or restoration. A recent academic study available on Archive about pavement performance models in South Carolina helps to show why the answer can't be summed up in one sentence. The researchers analyzed 20 sections of primary and interstate highways, creating 8 performance models, 4 for asphalt pavements and 4 for jointed concrete pavements, and evaluated indicators such as roughness, quality, defects, and riding conditions. The results showed that average daily traffic, free flow speed, and precipitation had significant effects on both systems, but temperature appeared as a significant factor for defect and quality indicators only in asphalt pavements. In other words, heat, load, and water do not affect all pavements in the same way. Concrete operates differently. Because it is a rigid pavement, it distributes loads better and tends to deform less under heavy traffic. This makes it interesting for logistics corridors and sections where asphalt shows recurring deformations. The main advantage of concrete is its durability. When well designed and executed, it may require fewer major interventions over time. This scenario does not mean there is no maintenance. Concrete pavement also needs joint control, sealing, slab repair, structural evaluation, and localized corrections. But the frequency of major restorations can be much lower under certain conditions. The disadvantage, on the other hand, is upfront. Concrete tends to cost more initially, requires more precise execution, strict quality control, and greater discipline on the job site. Poorly done repairs can cause discomfort, noise, or joint failures. At this point, an important alternative comes into play: the RCC, or roller compacted concrete. It uses cement, aggregates, and water, but with low moisture, forming an almost dry mixture, similar to damp soil or slightly moistened gravel. Unlike conventional concrete, RCC is not poured with the same fluidity, does not rely on traditional forms, and is compacted with rollers in a process similar to earth-moving operations. This brings RCC closer to the operational reality of roads here in Brazil. It can be spread by equipment similar to those used in asphalt paving and compacted by heavy machinery. When well executed, it offers high rigidity, good load distribution, and less tendency to permanent deformations. The trade-off is really clear. Asphalt wins in initial cost, speed, and simple maintenance. Concrete comes out ahead when the equation includes heavy traffic, durability, less deformation, and costs over decades. Therefore, the best choice doesn't depend only on the material, but on the right question. How much does it cost to build, maintain, close, and rebuild that highway throughout its entire lifespan? Game. A highway doesn't age by the calendar. It ages under the truck's axle, from the water that seeps in, from the heat that deforms the surface, and from maintenance that needs to be done sooner than it should. That's why comparing asphalt and concrete requires numbers, not guesses. An analysis conducted by researchers at MIT using data from the Federal Rail Administration evaluated 5,643 highway sections in the United States. The conclusion estimated that more rigid surfaces could save up to 273 million barrels of oil per year, avoid 46.5 million metric tons of CO2, and reduce about $15.6 billion in fuel costs. Another study conducted on 20 road sections in South Carolina created 8 performance models, 4 for asphalt pavements and 4 for jointed concrete pavements. The research showed that traffic, speed, and precipitation affect both systems, but temperature appeared as a significant factor in defect and quality indicators only in asphalt. Studies and technical references usually work with design life, not with guaranteed lifespan. In general terms, Flexible pavements, such as asphalt pavements, are often designed for about 20 to 30 years. Rigid pavements, such as concrete ones, are cited in international references with a typical design life of 30 to 40 years. The international case helps explain this difference. In Minas Tirith, in the state of Michigan, the director of public works stated that concrete streets could last 3 times longer than asphalt ones, although they cost about twice as much to build. These examples don't mean that a Brazilian highway would have exactly the same performance as an American road. They show the logic behind the calculation. When maintenance adds up over decades, the lower initial cost doesn't always represent the lowest final cost. With asphalt, this calculation tends to involve resurfacing, reinforcements, and recurring repairs. With concrete, it tends to focus on joints, slabs, and localized repairs. The question isn't just whether the lower initial cost remains cheap after 30 years, but rather which concrete technique would be suitable for the Brazilian scenario. Brazil doesn't change on a large scale because the decision isn't just technical, it's economic, political, and operational. But maybe Brazil needs to start asking an uncomfortable question. Why do we keep treating asphalt as the standard answer for almost all roads, even in a country with a tropical, hot, humid climate and heavy traffic? In many Brazilian regions, asphalt pavement faces a tough combination: intense heat, heavy rain, temperature changes, and loaded trucks passing by every day. Over time, this combination accelerates deformations, creates wheel ruts, opens cracks, and eventually turns the road into a series of potholes. And when that happens, the problem is no longer just about the road. It affects the driver's wallet and daily life. A deformed road forces the driver to slow down, swerve, brake suddenly, and deal with constant traffic jams. In some stretches, a trip that should be simple turns into an endless wait. This is where concrete, especially RCC roller compacted concrete, comes in as a strategic alternative for Brazil. Unlike conventional concrete, RCC has a drier consistency and can be applied with equipment similar to that used in asphalt paving projects, such as motor graders, pavers, and rollers. This allows for faster construction with high structural strength and great capacity to support heavy loads. In practice, RCC can function as an extremely strong base for rigid pavements, reducing deformations and increasing the durability of the structure. This technology may make more sense than insisting on solutions that require frequent maintenance. The point is not to say that asphalt should disappear. It has its place, its function, and its advantages. But Brazil needs to stop choosing pavement only based on the initial construction cost. A road that's cheap to build can become way too expensive when it starts leading to pothole repairs, resurfacing, closures, accidents, traffic jams, and daily losses for those who depend on it. In the end, a highway shouldn't be evaluated just by the price per kilometer built, but by the cost it imposes on the country throughout its useful life. And maybe that's exactly why concrete paving, especially with RCC, deserves more attention. Because in a hot, freight-heavy, and road-dependent Brazil, the road of the future might not be just another layer of asphalt, but a structure designed to withstand time, weather, and the real weight of the Brazilian economy. Thank you for watching this video until the end. Knowing that Brazil has its shortcomings when it comes to building roads, wouldn't it be more interesting if roads were made with concrete instead of asphalt? Especially with RCC technology. What do you think about that? Yes or no? And if yes, which road do you think should be built with concrete today? Leave your opinion in the comments. I'll be happy to read all of them. That's it from me for now. Sending you a big hug, and I'll see you in the next video.